Welcome back to the quiet. Settle in, let your shoulders soften, and allow the weight of the day to completely dissolve as we spend the next hour drifting outward, past the city lights and beyond the blue curve of Earth. Tonight, you have nowhere else to be, and you are safe to simply let go. We will float gently through the vast, dark mysteries of the cosmos, from ancient starlight to wandering planets, moving at a pace designed for perfect peace. So just breathe, close your eyes, and let my voice guide you into a deep, uninterrupted rest as we begin. Chapter 1. The Vastness of the Universe. When we look up at the night sky, it can feel as though we're seeing the whole universe spread out above us. In reality, what we're looking at is only a tiny neighborhood of something unimaginably vast. Our home, the solar system, is just one small region within the Milky Way, a spiral galaxy filled with hundreds of billions of stars. And the Milky Way itself is only one galaxy among perhaps 2 trillion scattered throughout the observable universe. Yet even within our own cosmic backyard, the solar system contains mysteries that challenge our imagination. Strange worlds, violent environments, and discoveries that continue to surprise astronomers remind us that space is far from empty. It's a place of constant motion and discovery. One of the most remarkable journeys into that frontier began in 2006 with the launch of the New Horizons spacecraft. After traveling for nearly a decade across billions of kilometers of space, the probe finally reached the distant dwarf planet Pluto in 2015. Until that moment, Pluto had been little more than a blurry point of light even in our best telescopes. What New Horizons revealed changed our understanding completely. Among the most striking discoveries was a vast region on Pluto's surface known as Tombaugh Regio, often nicknamed Pluto's heart. This enormous bright plane appears remarkably smooth and almost free of impact craters. In planetary science, that's a surprising clue. A surface without many craters usually means it's geologically young. In fact, researchers estimate parts of this region may have been reshaped within the last 100 million years, an extremely short period in cosmic terms. The terrain itself is equally strange. Some areas resemble cracked mud flats stretching for miles, while others form gentle hills or deep troughs that cut across the icy surface. Scientists suspect that slow convection currents inside Pluto's frozen nitrogen ice may be constantly reshaping the landscape. In other words, even in the deep cold of the outer solar system, Pluto may still be quietly active beneath its icy crust. But while Pluto represents the frozen edge of our planetary system, other worlds are defined by fire. Far beyond Earth, astronomers have discovered planets so extreme they seem almost fictional. One example is K2 141b, located roughly 200 light-years away. This world orbits incredibly close to its parent star, completing an orbit in less than a single Earth day. Conditions there are almost impossible to imagine. The side facing its star is permanently exposed to blazing heat, with temperatures exceeding 3,000 degrees Celsius, hot enough to vaporize rock. Scientists believe much of its surface may be covered by oceans of molten lava. Meanwhile, the opposite side of the planet lies in perpetual darkness, far colder and dramatically different from its scorched twin hemisphere. Violent winds may carry vaporized rock through the atmosphere, where it cools and falls again like stone rain. Even within our own solar system, there are places that resemble such alien extremes. One of the most dramatic is Io, a moon orbiting the giant planet Jupiter. Io is the most volcanically active world known. Its surface is dotted with hundreds of volcanoes constantly erupting sulfur and molten rock. Beneath its crust lies a vast ocean of magma, kept molten by powerful gravitational forces as Jupiter's immense gravity stretches and compresses the moon. The result is a world that seems almost alive with fire, towering volcanic plumes, glowing lava lakes, and an atmosphere filled with toxic sulfur dioxide. Combined with Jupiter's intense radiation belts, Io would be one of the most hostile places imaginable for any spacecraft or any form of life. Of course, observing these distant worlds requires remarkable tools. For decades, one of the most important of these has been the Hubble Space Telescope. About the size of a school bus, Hubble circles Earth at an altitude of roughly 540 kilometers, moving at nearly 27,000 kilometers per hour. From this vantage point above Earth's atmosphere, Hubble has captured some of the most detailed images of the universe ever recorded. It has observed galaxies more than 13 billion light-years away, meaning the light it sees today began its journey when the universe was still very young. Over the years, astronauts aboard the space shuttle even visited the telescope several times, performing delicate repairs and upgrades that extended its life far beyond what anyone expected. But space exploration isn't only about distant galaxies. Sometimes the dangers are much closer to home. For astronauts walking on the moon, one of the most surprising hazards is something that seems harmless: dust. Lunar dust may look like ordinary gray powder, but under a microscope, it tells a different story. Because there is no wind or water on the moon to wear it down, the tiny particles remain jagged and razor sharp. Much of it is created by countless meteorite impacts that shatter rock into microscopic fragments. When researchers studied lunar dust in laboratories, they discovered it could be extremely harmful to human tissue. The particles can damage cells and cause serious lung irritation if inhaled. During the Apollo missions, astronauts even reported a strong smell similar to burnt gunpowder after tracking the dust inside their spacecraft. Space, it turns out, has dangers that are both enormous and microscopic. And sometimes, space presents mysteries that appear and disappear almost as quickly as they are discovered. In 2008, astronomers analyzing images from the Hubble Space Telescope announced something remarkable: the first visible light detection of an exoplanet orbiting the bright star Fomalhaut. The object was named Fomalhaut B. For a few years, it seemed like an extraordinary breakthrough. But as astronomers continued observing the system, the object began to fade and eventually disappeared from view. Later studies suggested it may not have been a planet after all, but rather an expanding cloud of debris from a massive collision between two large bodies, an event we were lucky enough to witness from across interstellar space. Moments like that remind us that the universe is not static. Even on cosmic timescales, dramatic events can unfold right before our eyes. And beyond these discoveries lies an even larger mystery. The universe itself is expanding. Galaxies are gradually drifting farther apart as space stretches between them. The cause of this acceleration may be something called dark energy, a force we still barely understand. Some speculative theories suggest that if this expansion continues to accelerate indefinitely, it could eventually lead to a dramatic scenario known as the Big Rip, where the fabric of space itself is pulled apart. Fortunately, if such a fate awaits the cosmos, it lies tens of billions of years in the future, far beyond any timescale that concerns us today. For now, we remain in a universe filled with extraordinary worlds, powerful forces, and discoveries still waiting to be made. And perhaps that is the most fascinating part of all. Even our tiny corner of the Milky Way holds more wonders than we could ever fully explore. Before we move on to the next chapter, here's a quick question for you. Which world do you think is more extreme? The volcanic chaos of Io, or the molten lava oceans of distant planets like K2-141b? Chapter 2: The Speed of Light and Cosmic Distances. Space has a strange way of playing tricks on our perception. When we observe distant objects in the universe, we are not seeing them as they are right now. We're seeing them as they were when their light first began its journey toward us. Because light travels at a finite speed, every glance into deep space becomes a glimpse into the past. Some stars appear to us as they were decades ago, while distant galaxies reveal what the universe looked like millions or even billions of years earlier. This concept becomes especially fascinating when astronomers re-examine old observations. A good example involves the star Fomalhaut. Years ago, images taken by the Hubble Space Telescope seemed to reveal a large planet orbiting this nearby star. The object was labeled Fomalhaut B and initially celebrated as one of the first planets ever photographed directly. But science is a process that evolves with time. In 2020, researchers revisited the original images and analyzed them more carefully. Instead of a planet, they found evidence that the object was likely a massive, expanding cloud of debris, the aftermath of a collision between two icy bodies, possibly large asteroids or protoplanets. What astronomers briefly thought was a distant world was actually a cosmic crash unfolding before our eyes. Even in astronomy, first impressions sometimes change. Closer to home, our own solar system holds equally captivating structures. One of the most recognizable is the magnificent ring system of Saturn. From afar, Saturn's rings appear smooth and continuous, like a shimmering disk surrounding the planet, but up close, they are anything but uniform. The rings are made of countless pieces of ice and rock, ranging from tiny grains to objects the size of houses. Within them are gaps and divisions sculpted by the gravity of small moons. One such opening is the Encke Gap, named after the German astronomer Johann Encke, who first identified it. Inside this gap orbits a tiny moon called Pan. Pan's gravity acts like a shepherd, pulling nearby particles aside and keeping the gap clear as it moves along its path. It's a delicate gravitational dance, one that reveals how even small objects can shape massive cosmic structures. Another nearby world tells a very different story about planetary evolution. Today, Venus is often described as Earth's evil twin. Its surface temperature averages around 465 degrees Celsius, hot enough to melt lead, and its thick atmosphere is filled with clouds of sulfuric acid. Any spacecraft attempting to land there faces crushing pressure and extreme heat. But Venus may not have always been this hostile. Some climate models suggest that billions of years ago, Venus could have possessed oceans of liquid water and conditions mild enough to potentially support life. Over time, however, the planet experienced a runaway greenhouse effect. As the sun's radiation intensified and water vapor accumulated in the atmosphere, Venus gradually lost its oceans. Solar radiation eventually stripped away much of its remaining water, leaving behind the scorching world we see today. The universe also contains objects far more extreme than any planet. Black holes, for instance, are regions where gravity becomes so powerful that nothing, not even light, can escape. While many black holes sit quietly at the centers of galaxies, some may wander through space after violent gravitational interactions. Astronomers believe that black holes can sometimes be ejected from their birthplaces, especially during collisions or mergers with other black holes. These rogue black holes would drift silently through the galaxy, invisible unless they interact with nearby matter. Though the idea may sound unsettling, the vast distances between stars mean the chances of one wandering near Earth are incredibly small. If we extend our view far beyond our galaxy, we begin to see the grand scale of the universe itself. One stunning example is the Whirlpool Galaxy, located about 23 million light-years away in the constellation Canes Venatici. This spiral galaxy is famous not only for its beauty, but also for its close interaction with a smaller companion galaxy, NGC 5195. As the two galaxies orbit each other, their gravitational forces stretch and twist their structures. Gas clouds compress within the spiral arms, triggering bursts of star formation. The glowing blue regions we see in photographs are vast stellar nurseries, places where new suns are constantly being born. Even events closer to Earth can reveal important clues about the universe. In astronomy, when one object passes directly in front of another from our viewpoint, the event is called an occultation. A familiar example occurs during a lunar eclipse when the moon moves through Earth's shadow and takes on a reddish color. Occultations also help astronomers detect double stars, pairs of stars so close together they appear as one point of light in a telescope. When the moon briefly blocks one of these stars, the tiny changes in brightness reveal that two stars are present instead of one. But not all hazards in space are distant or theoretical. Surrounding Earth itself is a growing cloud of debris, fragments from old satellites, rocket parts, and other human-made objects. Organizations such as the U.S. Space Force track tens of thousands of pieces of space debris orbiting the planet. These objects travel at incredible speeds, often around 28,000 kilometers per hour. At such velocities, even something the size of a marble could severely damage a spacecraft. Larger fragments pose an even greater risk to satellites and to astronauts working outside their vehicles during spacewalks. The challenge of managing space debris is becoming one of the major concerns for future space missions. And speaking of astronauts, many people have wondered what would actually happen if someone were suddenly exposed to the vacuum of space without a protective suit. Contrary to popular movies, a person would not instantly freeze or explode. However, the experience would still be extremely dangerous. Without atmospheric pressure, oxygen in the bloodstream would quickly drop, leading to unconsciousness within about 10 to 15 seconds. Moisture in the body could begin to vaporize, causing swelling and other severe effects. While rescue might still be possible if it happened briefly, survival would depend on rapid recovery and medical care. Space is beautiful, but it is also unforgiving. Even seemingly mysterious discoveries sometimes turn out to have simple explanations. In 2015, images from the Curiosity rover sparked curiosity when observers noticed what looked like a floating spoon on the surface of Mars. Some people imagined unusual structures or artificial objects. In reality, the formation was simply an oddly shaped rock balanced on a thin pillar of stone, a natural product of erosion over millions of years. Our minds often try to find familiar shapes even in the most alien landscapes, and that might be the most fascinating part of exploring space. The more we learn, the more surprises we encounter. Some discoveries turn out to be different than we first expected. Others reveal entirely new questions waiting to be answered. As we continue looking deeper into the cosmos, every observation reminds us that the universe is vast, dynamic, and still full of mysteries. Before we move on, here's a question for you. If you could witness one cosmic event up close, a supernova explosion, a planetary collision, or the swirling birth of stars inside a galaxy, which would you choose? Chapter 3. The Birth of Stars. Space exploration often begins with curiosity, and sometimes with a little bit of imagination. A perfect example came in 2015 when images sent back by the Curiosity rover sparked a wave of excitement online. In one photograph taken on the dusty surface of Mars, observers noticed something unusual, a rock formation that looked remarkably like a floating spoon. For a brief moment, speculation ran wild, but scientists quickly explained the reality behind the curious shape. The spoon was simply a rock sculpted by millions of years of Martian wind erosion. A thin pillar of stone supported a small rounded rock, while the angle of the sunlight cast a shadow that made the illusion even stronger. It was a reminder that our minds naturally search for familiar shapes, even on alien worlds. Yet, while some mysteries turn out to have simple explanations, others reveal phenomena far more powerful than anything we experience on Earth. Across the universe, some of the most dramatic displays come from the environments surrounding black holes. In certain galaxies, supermassive black holes at their centers launch enormous streams of charged particles known as extragalactic jets. These jets shoot out from the regions around the black hole at nearly the speed of light, forming colossal beams that can stretch for millions of light years into intergalactic space. If you could see one up close, it might resemble a cosmic spotlight cutting through darkness. But these are no gentle beams of light. They are torrents of high-energy particles and radiation capable of heating surrounding gas to incredible temperatures. Astronomers detect them from vast distances because they glow brightly in radio waves, X-rays, and other wavelengths. Even from across the universe, they signal the presence of some of the most energetic processes known. Meanwhile, much closer to home, our own star is constantly producing the light that makes life possible on Earth. But even sunlight has its own hidden story. Inside the core of the sun, nuclear fusion creates immense amounts of energy. The photons generated there do not travel directly outward. Instead, they bounce around inside the sun's dense interior for an incredibly long time, often tens of thousands of years. Eventually, after this slow and chaotic journey through the sun's layers, those photons reach the surface and escape into space. From there, the final leg of the trip is surprisingly quick. Traveling at the speed of light, sunlight crosses the roughly 150 million kilometers between the Sun and Earth in about 8 minutes and 20 seconds. So when sunlight warms your face on a bright day, the energy behind it may have begun its journey inside the Sun thousands of years ago. While stars sustain life from afar, human explorers have begun testing what it means to live beyond Earth's environment. One of the most fascinating studies of long-term space travel involved the identical twin astronauts, Scott Kelly and Mark Kelly. In what became known as the NASA Twins Study, Scott Kelly spent nearly a full year aboard the International Space Station, while his brother Mark remained on Earth. Because they share nearly identical DNA, scientists were able to compare how spaceflight affected Scott's body. Researchers found several temporary changes during his mission: slight shifts in gene activity, changes in immune response, alterations in body mass, and even subtle changes in eye shape caused by fluid redistribution in microgravity. Fortunately, most of these effects gradually returned to normal after Scott returned to Earth. Experiments like these help scientists understand what future astronauts might experience during long missions to the Moon, Mars, or beyond. While humans study the effects of space on biology, astronomers continue uncovering extraordinary phenomena across the solar system itself. One of the most visually striking is found at the North Pole of Saturn. There, swirling in the planet's atmosphere, lies a mysterious six-sided storm known as Saturn's hexagon. First observed by spacecraft in the 1980s, this enormous atmospheric vortex is large enough to fit several Earths inside it. The storm rotates roughly once every 10 hours and has persisted for decades, possibly even centuries. Scientists believe the hexagon forms because of complex wind patterns deep within Saturn's atmosphere. Jet streams moving at different speeds create boundaries where the airflow organizes itself into a remarkably stable geometric shape. The result is one of the most unusual weather systems known anywhere in the solar system, a planetary storm shaped like a perfect polygon. Elsewhere in the universe, planets themselves can take on unexpected forms. We often picture planets as nearly perfect spheres, but technically even Earth is slightly flattened at the poles due to its rotation. Astronomers describe this shape as an oblate spheroid. However, not all planets follow that rule. A distant exoplanet called WASP-103b has been observed with a noticeably stretched shape. Located about 1/200 light-years away, this planet orbits extremely close to its parent star. The intense gravitational pull of the star distorts the planet itself, stretching it into an elongated form somewhat like a rugby ball. This effect, known as tidal deformation, is a far more extreme version of the same gravitational forces that cause ocean tides on Earth. Closer to home, gravity also explains one of the most curious experiences of spaceflight: weightlessness. Many people assume astronauts float because there is no gravity in orbit, but that isn't quite true. At the altitude of the International Space Station, roughly 400 kilometers above Earth, gravity is still about 90% as strong as it is on the ground. The reason astronauts appear weightless is that both they and the space station are constantly falling toward Earth. However, they are also moving sideways at tremendous speed, about 28,000 kilometers per hour. This forward motion causes them to fall along Earth's curved surface rather than straight down. In essence, the station is perpetually falling around the planet. This continuous freefall creates the sensation of weightlessness inside the spacecraft, allowing astronauts to float effortlessly as they conduct experiments and observe Earth from above. From windswept rocks on Mars to distorted exoplanets and colossal jets from distant black holes, the universe is filled with astonishing diversity. And at the center of many of these phenomena lies the life cycle of stars. Stars are born from clouds of gas and dust, shine for millions or billions of years, and eventually reach dramatic endings that reshape the cosmos around them. Their deaths scatter the raw materials that form new stars, planets, and perhaps even life itself. In that sense, the story of stars is also the story of everything that exists, including us. Before we continue to the next chapter, here's something to think about. If you could witness one cosmic phenomenon in person, would you choose the towering jets from a distant black hole or the massive hexagon storm swirling on Saturn? Chapter 4. The Life and Death of Stars. The universe often feels timeless when we gaze at the night sky, yet every star we see is part of a story with a beginning and an end. Stars are born. They live brilliant lives burning through unimaginable amounts of fuel, and eventually they fade or explode. It's a cosmic cycle that has shaped galaxies for billions of years, but occasionally the universe surprises us. Astronomers have observed rare objects that appear to defy this simple life and death rule. Some stars seem to explode in what should be their final supernova, and then brighten again later, as if they survived the catastrophe. These strange objects are sometimes nicknamed zombie stars. Instead of being completely destroyed, something within them reignites or re-energizes the star, making it appear as though it has returned from the dead. Scientists are still studying these events carefully, trying to understand whether unusual stellar structures or incomplete explosions might explain the phenomenon. The cosmos also contains layers of complexity that can feel almost playful. We are familiar with planets orbiting stars and moons orbiting planets, but astronomers have wondered about an even stranger possibility: moons that have their own moons. These hypothetical bodies are sometimes called submoons or moon moons. If they exist, they would orbit a larger moon, which itself travels around a planet. While no confirmed submoon has been discovered yet, researchers have begun studying whether such systems could remain stable for long periods of time. Under the right conditions, a large moon orbiting far from its planet, a tiny companion might indeed circle it. Somewhere in the vastness of the galaxy, there could be a moon casting shadows across its own miniature satellite. Water, the ingredient we associate most closely with life, is not unique to Earth either. Modern telescopes have detected signs of water vapor far beyond our solar system. One fascinating example is an exoplanet called TOI 674b, located roughly 150 light-years away. This world belongs to a class astronomers sometimes compare to super Neptunes, planets with thick atmospheres and sizes much larger than Earth. Observations suggest that its atmosphere contains water vapor, hinting at complex chemistry taking place high above its surface. While this doesn't mean the planet hosts life, its environment is likely far too extreme. Discoveries like this help scientists understand how water behaves across the galaxy and how planetary atmospheres evolve over time. Thinking about such distant worlds naturally leads to another question. Just how far away are the objects in our own cosmic neighborhood? Even our closest star, the Sun, is astonishingly distant by human standards. Imagine attempting the journey using everyday transportation. Driving a car at about 60 miles per hour non-stop would take well over 170 years to reach the Sun. Flying at typical passenger jet speeds would still require nearly 2 decades. And if someone attempted the impossible task of walking there at a steady pace, the journey would stretch thousands of years. These thought experiments highlight the enormous scale of space, distances so vast that human intuition struggles to grasp them. Despite those distances, humanity has already begun living and working just beyond Earth's atmosphere aboard the International Space Station. Life in orbit, however, brings unexpected challenges. Astronauts often experience changes to their bodies due to the absence of gravity. One of the most puzzling conditions is known as spaceflight-associated neuroocular syndrome, or SANS. Many astronauts returning from long missions report changes in their vision, including temporary farsightedness or structural changes in the eye. Scientists believe fluid shifts inside the body and microgravity may increase pressure around the brain and eyes, subtly altering vision. Understanding this condition is critical as space agencies plan longer missions to the Moon and eventually Mars. Space continues to deliver mysteries that push our understanding even further. In 2017, astronomers using the Pan-STARRS telescope in Hawaii detected an unusual object passing through our solar system. At first, it seemed like a comet, but it lacked the glowing tail that comets typically display. Then scientists considered whether it might be an asteroid, yet its motion and shape didn't quite match that explanation either. Eventually, the object was named Oumuamua, a Hawaiian phrase meaning a messenger from afar arriving first. It turned out to be the first known visitor from another star system ever observed passing through ours. Long and tumbling through space, it likely formed around a distant star billions of years ago before being ejected into interstellar space, wandering the galaxy until it briefly crossed our path. Our ability to detect such wonders owes much to one of humanity's greatest scientific instruments, the Hubble Space Telescope. Orbiting Earth at roughly 17,000 miles per hour, Hubble has spent decades capturing breathtaking images of galaxies, nebulae, and distant stars. Beyond the beauty of its photographs, Hubble has also helped scientists observe something extraordinary: the early stages of planet formation around young stars. Within swirling disks of gas and dust known as protoplanetary disks, gravity gradually pulls material together to form planets. In some cases, astronomers have even detected sudden bursts of energy associated with these violent formation processes, offering a rare glimpse into how new worlds take shape. Humanity has also tried to leave its own message in the cosmos. In the early 1970s, NASA launched the Pioneer 10 and Pioneer 11 spacecraft to explore the outer solar system. Attached to each probe was a small metal plaque engraved with diagrams explaining humanity's location in the galaxy, the structure of hydrogen atoms, and even simple images of human beings. The idea was simple but profound. If an intelligent civilization ever encountered the spacecraft, the plaque might serve as a greeting from Earth. A few years later, the Voyager 1 and Voyager 2 probes carried this idea even further by including golden records. These records contain sounds of nature, greetings in dozens of languages, music from around the world, and images representing life on Earth, a time capsule drifting through interstellar space. And yet, despite all the warmth of stars and the messages we send into the void, the universe itself is incredibly cold. Far beyond our solar system lies a strange object known as the Boomerang Nebula, currently considered the coldest natural place ever discovered. Temperatures there drop to about 458 degrees C, 272 degrees C, even colder than the faint afterglow of the Big Bang that fills the universe. Astronomers believe this extreme chill occurs because gas within the nebula is expanding extremely rapidly. As it rushes outward, it cools dramatically, creating a region colder than almost anywhere else known in space. When we step back and look at all of these discoveries, resurrecting stars, wandering interstellar visitors, possible moons, and messages drifting between the stars, the universe begins to feel less like a silent void and more like an ongoing story. Every new observation reveals another layer of complexity and mystery. The life and death of stars may shape galaxies, but the details of that cosmic drama are still unfolding before our eyes. And perhaps that's the most exciting part. We're only beginning to understand it. Trivia for you. Oumuamua was the first known object detected in our solar system that originated from outside it. But do you know roughly how fast it was traveling as it passed near the Sun? Chapter 5. Black Holes, the Cosmic Monsters. Space is filled with places so extreme that they seem almost impossible to imagine. One such region is the Boomerang Nebula, a strange cloud of gas and dust drifting about 5,000 light-years from Earth. Astronomers believe this nebula formed after a dramatic stellar interaction, possibly when two stars collided or when one dying star violently expelled its outer layers. The gas expanded outward at incredible speeds, cooling so dramatically that the nebula became colder than the natural background temperature of the universe itself. It is the coldest known natural place in the cosmos. While it is far too distant to threaten us, it stands as a reminder that space contains environments unlike anything we could ever survive. If humanity ever masters interstellar travel, the Boomerang Nebula might be one destination best admired from a safe distance. Yet, temperature extremes are only one of the universe's many surprises. Astronomers have also detected enormous cosmic structures that challenge our understanding of how matter behaves on the largest scales. One of the strangest discoveries is a massive radio-emitting formation informally nicknamed the cosmic jellyfish. This enormous structure, stretching across millions of light years, appears as a network of charged particles and magnetic fields glowing in radio wavelengths. It resembles tentacles spreading through the darkness of space. Objects like this are classified as giant radio sources, and they are often linked to powerful galaxies with supermassive black holes at their centers. The energy released from those black holes can shoot vast jets of particles across unimaginable distances, creating structures so large they dwarf entire galaxies. While some cosmic structures are unimaginably large, others are defined by extreme density. When a massive star reaches the end of its life, it may explode in a spectacular supernova. What remains afterward can be one of the most extraordinary objects in existence, a neutron star. These stellar remnants pack more mass than the Sun into a sphere only about 20 kilometers across. The result is an object so dense that a single teaspoon of its material would weigh billions of tons on Earth. Many newborn neutron stars spin incredibly fast, sometimes hundreds of times per second, turning them into what astronomers call pulsars, beams of radiation sweeping through space like cosmic lighthouses. Their gravity and magnetic fields are so powerful that any ordinary matter that gets too close is ripped apart at the atomic level. And yet even neutron stars are overshadowed by something even more terrifying: black holes. These objects represent the ultimate triumph of gravity. When an extremely massive star collapses under its own weight, it can form a region of space where gravity becomes so intense that nothing, not even light, can escape. The boundary surrounding this region is known as the event horizon. Crossing that invisible border would be a one-way journey. According to physics, anyone falling into a black hole would experience an extreme stretching effect caused by the difference in gravitational pull between the top and bottom of their body. This phenomenon has an oddly humorous name: spaghettification. As the gravitational forces increase, a falling object would be stretched thinner and thinner, like strands of spaghetti, before eventually being torn apart. Despite these terrifying cosmic monsters, space also contains wandering visitors that follow quieter paths. In the distant outskirts of our solar system lies the Oort cloud, a vast spherical shell filled with icy remnants from the early days of planetary formation. This region may contain billions or even trillions of frozen objects. Occasionally, gravitational disturbances send one of these icy bodies drifting toward the inner solar system, where it becomes a comet. In 2013, astronomers witnessed a remarkable event when one such comet plunged directly into the Sun. Using images captured by the Solar and Heliospheric Observatory spacecraft, scientists watched the comet make its final approach before it completely disintegrated in the Sun's intense heat and radiation. Beyond our solar system, astronomers continue discovering planets that seem almost alien in their nature. One example is TOI 452b, a planet often described as a potential water world. Measurements of its size and density suggest that a large portion of its mass could be made up of water or thick layers of ice beneath its atmosphere. Located roughly 100 light-years away, it is significantly larger than Earth, yet not quite a gas giant like Neptune. If the theories about its composition are correct, the planet could be covered by global oceans hundreds of kilometers deep, an environment unlike anything in our own planetary neighborhood. Then, there are planets that are strange in an entirely different way. TOI 3757b, for instance, has been described as one of the fluffiest planets ever discovered. Orbiting a small red dwarf star, this planet has an unusually low density. In fact, scientists estimate that it is so light and inflated that it resembles the consistency of a marshmallow compared to other planets. The leading explanation is that the planet formed around a star with fewer heavy elements, preventing it from gathering dense materials during its early formation. The result is a giant, puffed-up world that challenges our assumptions about how planets should look and behave. When we zoom out and consider the scale of the universe itself, these discoveries become even more astonishing. Astronomers estimate that the observable universe may contain roughly 300 sextillion stars. That's a 3 followed by 23 zeros. Each of those stars could host planets, moons, and possibly life. The numbers are so enormous that they almost lose meaning, reminding us that the cosmos is far larger and more populated than we once believed. Our journey into space, however, began with small and sometimes controversial steps. Before humans ever left Earth's atmosphere, scientists needed to understand how living organisms would react to space. Early space programs from both the United States and the Soviet Union sent animals, dogs, monkeys, and chimpanzees into orbit to study the effects of weightlessness and cosmic radiation. These missions helped researchers gather crucial data that eventually made human spaceflight possible. While those pioneering animals are long gone, some of the spacecraft that carried them still remain in orbit or drifting through space, silent reminders of the earliest experiments that paved the way for modern exploration. Even the galaxies themselves can form curious arrangements. One famous example is Stephan's quintet, a compact group of 5 galaxies located about 290 million light-years away. When astronomers first observed them in the late 19th century, they believed these objects were merely clouds of gas within our own Milky Way. Only later did scientists realize they were actually separate galaxies interacting with each other through gravity. Collisions between them trigger enormous shock waves and bursts of star formation, offering astronomers a front-row seat to the chaotic dance of galaxies. From frozen nebulae and fluffy planets to black holes that stretch matter like spaghetti, the universe continues to reveal extremes that challenge our imagination. Each discovery expands our understanding of what is possible in the cosmos and reminds us that even the strangest phenomena may simply be part of nature's grand design. And perhaps the most intriguing question of all is how many more cosmic monsters are still waiting to be discovered. Trivia for you. Black holes themselves can't be seen directly, but do you know what phenomenon around them allows astronomers to detect their presence from millions of light-years away? Chapter 6: Neutron Stars and Pulsars. As astronomical instruments became more powerful over the decades, scientists began to notice something peculiar in a small group of galaxies known as Stephan's quintet. At first glance, the 5 galaxies appear tightly clustered together, almost as if they are tangled in a gravitational embrace. Faint streams of gas and stars stretch between them, creating the impression that they are physically interacting. But when astronomers measured the redshift of the galaxies, the stretching of light that reveals how fast objects are moving away from us and therefore how far away they are, an unexpected mystery emerged. 4 of the galaxies seemed to be located about 300 million light-years away, while the 5th appeared to be much closer, at roughly 30 million light-years. The visual illusion of them being connected clashed with the measurements, creating a puzzle that astronomers debated for years. Today, scientists understand that one of the galaxies is actually a foreground object merely aligned by chance along our line of sight, while the other 4 are genuinely interacting. But for a time, the mystery challenged the reliability of redshift itself, a reminder that even the tools we trust most in science sometimes face puzzling exceptions. Water, another seemingly familiar substance, also carries an incredible story when viewed on a cosmic scale. The molecules that make up water, hydrogen and oxygen, originate in very different chapters of the universe's history. Hydrogen was forged in vast quantities during the Big Bang, and today it makes up about 3/4 of the visible matter in the cosmos. Oxygen, however, is much rarer. It forms deep inside massive stars during nuclear fusion and is scattered into space when those stars explode as supernovae. Because of this, water is actually far less common in the universe than hydrogen alone. Yet astronomers have found water vapor drifting through nebulae, locked inside comets, embedded in asteroids, and even floating within distant planetary systems. Some scientists believe that early in Earth's history, icy asteroids and comets delivered much of the water that now fills our oceans. In other words, every glass of water we drink may contain molecules that once traveled through interstellar space billions of years ago. When we look at planets themselves, the diversity becomes even more fascinating. In our own solar system, the planets fall into two broad categories. The first group is the terrestrial planets, rocky worlds with solid surfaces composed mainly of metals and silicate minerals. Mercury, Venus, Earth, and Mars all belong to this family. These are the kinds of worlds where spacecraft can potentially land, where mountains rise and valleys stretch across a tangible surface. The second group consists of the gas giants, Jupiter, Saturn, Uranus, and Neptune. These enormous planets are dominated by thick atmospheres of hydrogen, helium, and other gases. Beneath their swirling cloud layers, pressure increases dramatically, and there is no solid surface in the traditional sense. If a spacecraft attempted to descend into a gas giant, it would likely be crushed by the immense pressure long before reaching the deeper layers. Winds on these planets can exceed the most powerful hurricanes on Earth, making them some of the most violent environments in our solar system. Yet astronomers suspect that the universe may also host a third category of planet known as a chthonian planet. These worlds may begin their lives as gas giants orbiting extremely close to their parent stars. Over time, the intense heat and radiation from the nearby star could strip away the planet's thick atmosphere, leaving only the dense core behind. What remains would be a strange, exposed remnant, the skeletal heart of what was once a massive gas giant. While scientists have identified a few candidates, fully confirmed examples remain rare, making chthonian planets one of the more intriguing possibilities in planetary science. The cosmos is not only visual, it also carries vibrations on unimaginable scales. In 2003, astronomers studying the Perseus galaxy cluster detected enormous pressure waves rippling through the hot gas surrounding a supermassive black hole. These waves were so powerful that scientists described them as the deepest sound ever detected in the universe. Of course, space is mostly a vacuum, so the sound could not travel the way it does in Earth's atmosphere. Instead, the waves moved through the superheated gas filling the cluster. When translated into a musical pitch, the tone corresponds to something like a B-flat, but an astonishing 57 octaves below middle C, far beyond the range of human hearing. It's a haunting reminder that even the quietest regions of space may contain invisible vibrations generated by the immense power of black holes. Occasionally, the universe produces images that seem almost playful by comparison. In 2014, NASA's Solar Dynamics Observatory captured a photograph of the sun that looked uncannily like a glowing jack-o'-lantern. The bright regions forming the eyes and mouth were actually areas of intense magnetic activity in the sun's atmosphere, known as the corona. These regions release enormous bursts of energy called solar flares. While the image made for a perfect Halloween post, it also served as a fascinating glimpse into the complex magnetic forces constantly reshaping our star. Closer to Earth, there is another subtle cosmic phenomenon visible under the right conditions: zodiacal light. Just after sunset or before sunrise, observers in dark locations can sometimes see a faint triangular glow stretching upward from the horizon. This gentle light is caused by sunlight reflecting off tiny grains of dust scattered throughout the inner solar system. These particles are leftovers from comet tails and asteroid collisions. Interestingly, astronomers have detected similar dust disks around other stars, suggesting that zodiacal light may exist in distant planetary systems as well. Despite centuries of study, even the definition of something as seemingly simple as a planet remains surprisingly controversial. In 2006, the International Astronomical Union established three main criteria. A planet must orbit the Sun, have enough mass for gravity to shape it into a nearly round form, and clear its orbit of other debris. This definition famously led to Pluto being reclassified as a dwarf planet, a decision that sparked passionate debate within the scientific community and among the public. Some astronomers argue for a broader definition based solely on an object's shape and mass. while others support the stricter criteria. The discussion continues today, reminding us that science is an evolving process rather than a fixed set of rules. Even the weather on other worlds can surprise us. On Earth, small swirling winds called dust devils occasionally dance across deserts, lifting sand into twisting columns. On Mars, however, these whirlwinds are far more dramatic. Martian dust devils can rise 10 times taller and 50 times wider than those on Earth, sweeping across the red planet's surface like wandering towers of dust. These powerful winds pose a potential risk to robotic explorers such as rovers and landers. Yet, in one famous instance, a dust devil unexpectedly cleaned accumulated dust off a rover's solar panels, restoring its power and extending its mission. What could have been a threat instead became an unlikely act of cosmic maintenance. From puzzling galaxy alignments to the ancient origins of water, from silent cosmic sound waves to towering Martian whirlwinds, the universe continues to reveal complexity at every scale. Each discovery reminds us that space is not a static emptiness, but a dynamic environment filled with forces, motion, and hidden connections. The more we learn, the more we realize how much remains unknown, especially when it comes to the strange remnants of dying stars like neutron stars and pulsars, whose extreme physics still challenge our understanding. And perhaps that's the beauty of exploring the cosmos. Every answer seems to lead to an even deeper question. Trivia for you. Pulsars are rapidly spinning neutron stars that emit beams of radiation like cosmic lighthouses. But do you know roughly how many times per second the fastest known pulsars can spin? Chapter 7. Our Solar System's Hidden Wonders. Space exploration often reveals surprising moments that remind us how dynamic our solar system really is. One such moment occurred on Mars during NASA's Spirit rover mission. Over time, thick Martian dust had built up on the rover's solar panels, slowly draining its power and threatening to end the mission. Then, a towering Martian dust devil swept past the rover, blowing the dust away and restoring its energy. What could have been a destructive storm ended up extending the rover's life and allowing it to continue exploring the red planet. The universe also has a way of producing familiar shapes in unexpected places. In 2016, images captured by NASA's Spitzer Space Telescope revealed two glowing nebulae, vast clouds where new stars are born, that appeared to resemble the famous Starship Enterprise from Star Trek. In a fun tribute to science fiction, NASA released the image on the 50th anniversary of the original Star Trek series, highlighting the connection between imagination and scientific discovery. Far beyond Mars lies Pluto, one of the most intriguing worlds in our solar system. When NASA's New Horizons spacecraft flew past it in 2015, it revealed a large bright region shaped like a heart called Tombaugh Regio. This icy plain is made mostly of frozen nitrogen that melts and refreezes as temperatures change. This process slowly circulates gases through Pluto's thin atmosphere, almost like the dwarf planet has a slowly beating heart. While Pluto drifts quietly at the edge of the solar system, the entire system itself is moving at incredible speed. Our Sun and all its planets travel around the Milky Way galaxy at about 828,000 kilometers per hour. Even at that speed, one full orbit around the galaxy takes roughly 230 million years. Astronauts also discovered unexpected challenges much closer to home. When Neil Armstrong and Buzz Aldrin first walked on the moon, they noticed that lunar shadows were incredibly dark. Without an atmosphere to scatter sunlight, any shaded area becomes nearly pitch black, making simple tasks surprisingly difficult during the Apollo missions. Despite centuries of study, mysteries still remain. Nearby Barnard's star, one of the closest stars to Earth, has been debated for decades as astronomers search for evidence of planets orbiting it. Meanwhile, scientists have also mapped the outer boundary of our solar system, discovering that the heliotail, the trailing edge of the sun's protective bubble, may resemble a giant four-leaf clover stretching billions of miles into space. Even our sun can remind us how powerful the universe is. In 2012, Earth narrowly missed a massive solar storm that passed through the region of space our planet had occupied just a week earlier. If it had struck directly, it could have caused widespread damage to satellites and power grids across the globe. From swirling Martian dust storms to icy plains on distant Pluto, our solar system is far from quiet. It is a constantly changing environment filled with hidden wonders that we are only beginning to understand. Trivia. Question: which spacecraft flew past Pluto in 2015 and gave us the first detailed images of the dwarf planet? Chapter 8. The Mystery of Dark Matter. When we look up at the night sky, it may seem calm and unchanging, but the universe is far more active and sometimes far more dangerous than it appears. Astronomers estimate that the chance of a truly catastrophic asteroid impact on Earth is roughly 1 in 1,000 over long timescales. While that might sound small, another threat is even more likely: a massive solar flare capable of disrupting modern technology. Scientists believe the probability of such an event occurring within the next century could be as high as 1 in 8. Our civilization depends heavily on satellites, electricity, and communication networks, which means powerful solar storms could have enormous consequences if they struck Earth directly. Fortunately, most close encounters in space pass without incident. In December 2018, a peculiar asteroid made a relatively close approach to Earth. Astronomers jokingly nicknamed it the Space Hippo because its shape resembled the bulky body of a hippopotamus. Measuring about 1.6 kilometers long, the asteroid passed roughly 2.9 million kilometers from our planet, close in cosmic terms, but still far beyond any real danger. The flyby allowed scientists to capture detailed observations of the object before it continued its quiet journey through the solar system. Another fascinating object in space is a rapidly spinning stellar remnant known as PSR B12557+12, often called Lich. This star is a pulsar, a type of neutron star that rotates incredibly fast while emitting beams of radiation from its magnetic poles. As it spins, those beams sweep through space like a cosmic lighthouse. Lich completes more than 160 rotations every second, sending rhythmic pulses of energy into the surrounding darkness. Even more fascinating, this pulsar hosts a system of planets, some of the first exoplanets ever discovered. Speaking of unusual celestial objects, Saturn remains one of the most remarkable planets in our solar system. Despite its enormous size, Saturn is surprisingly light for a planet of its scale. In fact, its average density is lower than that of water. Theoretically, if you had an unimaginably large ocean or container of water, Saturn would float. Of course, with a diameter of more than 116,000 kilometers, finding a glass large enough for that experiment might be the real challenge. Meanwhile, astronomers constantly track asteroids that cross Earth's orbital path. One notable example is asteroid 2001 FO32, which made a close approach to Earth in March 2021. This space rock is estimated to be several hundred meters wide, large enough that, if it ever struck Earth, it could cause widespread destruction. Classified as a potentially hazardous asteroid, it belongs to the Apollo group, meaning its orbit regularly crosses Earth's path around the Sun. Thankfully, calculations show that it poses no impact risk for at least the next century. But not every object in space is a threat. Some are fascinating clues about how planets form. When stars are born, they leave behind swirling disks of gas and dust. Over time, tiny particles begin sticking together, gradually forming larger bodies known as planetesimals, the building blocks of planets. In 2019, NASA's New Horizons spacecraft photographed one of these ancient relics in the distant Kuiper Belt. The object, officially named Arrokoth, formerly nicknamed Ultima Thule, has a shape resembling a cosmic snowman. Scientists believe it formed when two smaller bodies slowly merged billions of years ago during the early formation of our solar system. The search for planets beyond our solar system also took a major leap forward in 1995, when astronomers discovered 51 Pegasi b. This was the first confirmed exoplanet orbiting a star similar to our Sun. Unlike the planets in our solar system, however, this world circles its star extremely quickly, completing an orbit in just 4 days. Its discovery opened the floodgates for one of the most exciting areas of modern astronomy. Today, thousands of exoplanets have been identified, revealing that planetary systems may be incredibly common throughout the galaxy. Closer to home, Mars offers another reminder that other worlds can have familiar yet very different climates. Like Earth, Mars experiences 4 seasons, caused by the tilt of its axis. However, because Mars takes nearly 687 Earth days to orbit the Sun, each Martian year is almost twice as long as ours. This means its seasons last much longer, and their lengths vary between hemispheres due to the planet's slightly elongated orbit. All of these discoveries, from spinning pulsars and wandering asteroids to distant exoplanets, help scientists piece together the grand puzzle of our universe. And yet, much of the cosmos remains mysterious. Astronomers believe that dark matter, an invisible form of mass, makes up most of the universe's matter, quietly shaping galaxies and cosmic structures through gravity. We cannot see it, but its presence is felt everywhere in the universe. Perhaps the greatest mystery of all is how much we still have left to discover. Trivia. Question: the first exoplanet discovered around a sun-like star was 51 Pegasi b, but do you know what nickname scientists often use for this extremely hot world? Chapter 9: Dark Energy and the Expanding Universe. When we imagine other planets, we often picture landscapes that behave somewhat like Earth. But the truth is that even familiar things like seasons can work very differently elsewhere in our solar system. Mars, for example, does experience 4 seasons similar to Earth's, caused by the tilt of its axis. However, a Martian year lasts about 687 Earth days, nearly twice as long as ours. This means its seasons stretch much longer. Spring alone in the northern hemisphere lasts roughly 7 Earth months. Because the Martian atmosphere is extremely thin, heat escapes easily into space. As a result, temperatures can vary dramatically even within a few meters. Near the equator at noon, the ground could feel pleasantly warm at about 75 degrees, 24 degrees Celsius, while the air just above might remain close to freezing. Life in space presents its own unique challenges as well. Astronauts living aboard the International Space Station, ISS, must deal with conditions that don't exist on Earth. One surprising issue is the buildup of carbon dioxide. In microgravity, the CO2 that astronauts exhale doesn't sink or disperse naturally. Instead, it tends to form a floating cloud around their heads. Even though the station uses ventilation systems to circulate the air, CO2 levels are still higher than those typically found on Earth. This can lead to headaches, sleep disturbances, and fatigue, symptoms many astronauts experience during the early days of their missions. Beyond human spaceflight, the universe itself continues to reveal stunning beauty. One of the most breathtaking examples captured by the Hubble Space Telescope is the Twin Jet Nebula, often nicknamed the Space Butterfly. Located thousands of light years away, this glowing nebula forms when a dying star ejects its outer layers into space. In this particular system, 2 stars orbit each other, one nearing the end of its life and the other a compact white dwarf. Their gravitational interaction shapes the expanding gas into 2 symmetrical wings of glowing material, giving the nebula its butterfly-like appearance. Astronomers have also discovered that planets come in more varieties than we once imagined. For centuries, scientists believed that planets were either rocky worlds like Earth or massive gas giants like Jupiter. But in recent years, researchers identified a new category known as gas dwarfs. These planets have a solid core similar to Earth's, but are surrounded by thick layers of hydrogen and helium gas. A well-known example is Kepler-11f, which is only a few times the mass of Earth, but still possesses a surprisingly dense atmosphere. Even our own moon hides a few surprises. At first glance, it appears perfectly round, but careful measurements reveal something slightly unusual. The moon is actually shaped a bit like a lemon, with subtle bulges along its sides. Scientists believe these distortions formed billions of years ago when Earth's gravity pulled on the moon while its interior was still molten. As the moon gradually moved farther away from Earth, its crust cooled unevenly, locking those slight bulges into place and giving the moon its unusual shape. Celestial events here on Earth can also produce strange effects. During a total solar eclipse, daylight briefly fades into darkness as the moon blocks the sun. Temperatures can drop quickly, winds may change direction, and wildlife often behaves as if night has suddenly arrived. Birds may stop singing, insects grow quiet, and some animals return to their shelters. Even radio signals can behave differently during an eclipse because the sudden loss of sunlight temporarily alters Earth's ionosphere, the electrically charged layer of the atmosphere that helps transmit radio waves. Our planet is also protected by an invisible shield, its magnetic field. This magnetic bubble deflects most of the charged particles streaming toward us from the sun. However, there is one unusual weak spot known as the South Atlantic anomaly. In this region, which stretches across parts of South America and the southern Atlantic Ocean, Earth's magnetic field dips closer to the surface. Satellites passing through this area are exposed to increased radiation, which can occasionally disrupt onboard electronics. To prevent damage, some spacecraft temporarily power down sensitive instruments while passing through the anomaly. The solar system's giant planets also display fascinating structures. Saturn, famous for its magnificent rings, contains enormous gaps within those rings. One of the largest is the Cassini division, a region roughly 4,800 kilometers wide where fewer ring particles exist. This gap is created by the gravitational influence of Saturn's moon Mimas, which subtly pulls on the surrounding ring material, preventing particles from gathering in that region. And finally, even the simplest necessities of life, like food, had to evolve during the early days of space exploration. In the earliest NASA missions, astronauts were given highly processed meals that many described as bland and unappealing. On one flight, an astronaut secretly brought a corned beef sandwich aboard. Unfortunately, the sandwich quickly crumbled in microgravity, scattering tiny crumbs throughout the cabin, a serious hazard for delicate spacecraft equipment. Today, meals on the ISS are carefully packaged to prevent floating debris, and astronauts can enjoy a much wider variety of foods. From the shifting seasons of Mars to the glowing wings of distant nebulae, the universe continues to reveal layers of complexity and wonder. And as our understanding grows, so does the realization that forces like dark energy, the mysterious phenomenon driving the expansion of the universe, are quietly shaping the cosmos on scales far beyond our everyday experience. The more we explore, the clearer it becomes. The universe is not only vast, but endlessly surprising. Trivia question: Saturn's largest ring gap is called the Cassini division. But do you know which moon's gravity helps create and maintain this enormous gap? Chapter 10: Exoplanets and Alien Worlds. Space may feel silent and distant when we look up at the night sky, but communicating across that vast distance is far more complicated than most people imagine. On Earth, phone calls happen almost instantly because signals only travel across a relatively small portion of our planet. In space, however, messages must cross enormous distances measured in millions of kilometers. Even our closest planetary neighbor can feel incredibly far away when it comes to communication. If astronauts were living on Mars, a simple radio message sent from Earth could take anywhere between about 4 and 21 minutes to arrive, depending on where the two planets are in their orbits. That means a full conversation, sending a message and waiting for a reply, could stretch to more than 40 minutes. At certain times, the Sun itself sits directly between Earth and Mars, flooding the space between them with solar radiation that disrupts radio signals. During these periods, communication can be almost impossible, leaving astronauts temporarily cut off from Earth and forced to solve problems entirely on their own. While we imagine future humans living on other worlds, astronomers are still discovering new ones even within our own solar system, or at least objects that might qualify as planets. In 2016, researchers from the California Institute of Technology proposed the existence of a mysterious Planet 9, a massive world possibly 10 times the mass of Earth. This hidden planet would orbit extremely far from the Sun, far beyond the icy region known as the Kuiper Belt. Scientists have never seen it directly, but they noticed something strange. Many distant icy objects seem to follow oddly aligned orbits, almost as if they are being pulled by the gravity of a large unseen body. Some astronomers have even suggested the possibility of another large object influencing the region. For now, these worlds remain hypothetical, but if they exist, they could reshape our understanding of the solar system. The idea of unusual planetary systems isn't limited to our own neighborhood. For decades, scientists wondered if planets could orbit more than one star at a time. It sounded like pure science fiction, something you might see in movies. In fact, the concept became famous through the desert world of Tatooine in the Star Wars universe, where two suns shine in the sky. But science eventually caught up with fiction. In 2011, astronomers confirmed the discovery of real planets that orbit two stars at once, known as circumbinary planets. On such worlds, sunsets could look spectacular, with twin stars dipping below the horizon together. These discoveries revealed that planetary systems across the galaxy are far more diverse and imaginative than anyone once believed. Life in space, however, brings challenges even before reaching another planet. Many astronauts discover that their bodies behave in strange ways once gravity disappears. Surprisingly, some astronauts experience stronger allergy symptoms in orbit, even though the air inside spacecraft is carefully filtered. Researchers believe the immune system may react differently in microgravity, and the stress of space travel can also play a role. Another common challenge is space adaptation syndrome, often described as a form of motion sickness in zero gravity. Without Earth's familiar pull, the inner ear struggles to determine which direction is up or down. Astronauts can feel disoriented, dizzy, and nauseous as their brains attempt to recalibrate to an environment where floating replaces standing. Meanwhile, far from Earth, spacecraft continue to uncover new wonders. During its mission around Saturn, NASA's Cassini spacecraft captured breathtaking images of the planet's rings and moons. Among its discoveries was evidence that a tiny new moon might actually be forming within Saturn's ring system. Scientists nicknamed this small object Peggy, a clump of icy material roughly 1 kilometer across that appears to be slowly gathering more particles from the surrounding ring. It offers a rare glimpse into a process that may have formed many of the moons we see today. Tiny pieces of ice gradually sticking together over time until they grow into fully formed worlds. Closer to home, astronomers also keep watch on objects that pass near Earth. One such asteroid, called Bennu, has attracted particular attention. Discovered in 1999, Bennu is about 500 meters wide and contains an enormous amount of mass. While the chances of it striking Earth are extremely small, roughly 1 in 2,700 over the next few centuries, scientists still study it closely. NASA's OSIRIS-REx mission even visited Bennu to collect samples, helping researchers better understand the composition of asteroids and how they formed during the early days of the solar system. Despite the vastness of space, humanity has already explored an incredible number of worlds, at least with robotic explorers. Spacecraft have flown past or orbited every major planet in our solar system, sending back images and data that transformed our understanding of the cosmos. Although humans have only walked on the moon so far, each robotic mission brings us one step closer to a future where people may one day set foot on distant planets as well. When we look up at the night sky, it's easy to forget how many mysteries are still waiting to be discovered. New planets, new moons, and new possibilities are constantly revealing themselves as our technology improves. The universe is not just larger than we imagined. It's also far stranger and more beautiful. Before we move on, here's a quick question for you. If you lived on a planet orbiting two stars, what do you think a sunset would look like? Chapter 11. The Search for Extraterrestrial Life. Humanity has not yet stepped foot on another planet, but our robotic explorers have already traveled far across the solar system. Over the past few decades, spacecraft have landed on asteroids, touched the surface of comets, and studied distant dwarf planets in remarkable detail. Some locations have even been visited multiple times as scientists attempt to piece together the history of our cosmic neighborhood. Each mission brings us closer to answering one of the biggest questions in science. Are we alone in the universe? Before spacecraft are even launched, scientists take extraordinary precautions to prevent biological contamination. If you've ever seen technicians working on spacecraft or inside the International Space Station, you may notice they often wear sterile suits that resemble those used in hospital operating rooms. The reason is simple. Microorganisms from Earth can be incredibly resilient, and sending them into space could accidentally contaminate other worlds. At the same time, we must also ensure that potential extraterrestrial microbes are not brought back to Earth without careful study. This discipline is known as planetary protection, and it plays a critical role in every space mission. One organism that perfectly illustrates the resilience of life is the bacterium Deinococcus radiodurans. Often called one of the toughest life forms ever discovered, this microscopic organism can survive radiation levels thousands of times higher than what would kill a human being. While just a few grays of radiation can be fatal to people, this bacterium can endure doses exceeding 5,000 grays. It has been found in unlikely places such as sewage, dust, and even spoiled food. Scientists often study it as a model for how life might survive in extreme environments, including the harsh conditions found on other planets. Clues about the origin of life may also be hiding inside comets. In 2015, astronomers studying Comet Lovejoy made an unexpected discovery. As the comet passed close to the Sun, the heat triggered the release of large amounts of organic molecules, including ethyl alcohol and simple sugars. In fact, at its peak, the comet was releasing alcohol equivalent to hundreds of bottles of wine every second. While that sounds almost humorous, the discovery carries serious scientific implications. These organic compounds are some of the basic ingredients needed to build complex molecules like DNA. This supports a fascinating theory suggesting that comets may have delivered some of the chemical building blocks of life to the early Earth billions of years ago. Our robotic missions continue to reveal surprising details about the planets themselves. One such mission was Messenger, a NASA spacecraft launched in 2004 to study Mercury, the smallest planet and the closest to the Sun. After a journey lasting several years, the spacecraft entered orbit around Mercury in 2011 and spent 4 years collecting data. During its mission, Messenger mapped the planet's surface in extraordinary detail and discovered that Mercury actually has a magnetic field, although much weaker than Earth's. The spacecraft also found that the planet's surface contains unusual amounts of elements like potassium, chlorine, and sulfur. Perhaps even more surprising was the discovery that Mercury is slowly shrinking. As the planet's interior cools over time, its metallic core and rocky layers contract. This causes the crust to wrinkle and buckle, creating enormous cliffs known as scarps that stretch for hundreds of kilometers. Scientists estimate that Mercury's diameter has decreased by several kilometers over billions of years. In other words, even the smallest planet in our solar system is still evolving long after its formation. While physical challenges dominate space exploration, psychological challenges may prove just as important. Astronauts aboard the International Space Station often report a powerful emotional experience when looking back at Earth from orbit. Seeing the blue planet floating in darkness can create a profound sense of connection to humanity. But as missions travel farther into space, perhaps toward Mars or beyond, that comforting view will slowly disappear. Researchers have even coined a term for this concern, the Earth out of view phenomenon. Some experts worry that prolonged isolation from our home planet could lead to intense homesickness, depression, or conflicts between crew members on long missions. As a result, space agencies are developing psychological support systems and training programs to help astronauts cope with the emotional challenges of deep space travel. Despite these difficulties, the search for life continues to focus on some of the most intriguing worlds in our solar system. One of the strongest candidates is Europa, one of Jupiter's largest moons. Beneath its thick, icy shell lies a vast global ocean of liquid water. Scientists believe this hidden ocean may be warmed by tidal forces generated by Jupiter's immense gravity. If hydrothermal vents exist on the ocean floor, similar to those found in Earth's deep oceans, they could potentially support simple life forms. Chemical reactions within Europa's ocean may even produce oxygen, creating an environment far more dynamic than once imagined. Back on Earth, our planet still holds a rare distinction. Water exists here naturally in all three states: solid ice, liquid oceans, and atmospheric vapor on a massive scale. This unique balance plays a crucial role in sustaining life and shaping our climate. While traces of water have been discovered elsewhere in the solar system, Earth remains the only known world where these three forms of water coexist so abundantly. Space exploration also carries difficult realities. So far, only 3 people have lost their lives during missions in space itself: Soviet cosmonauts Georgy Dobrovolsky, Vladislav Volkov, and Viktor Petsayev, who died in 1971 when their spacecraft, Soyuz 11, depressurized during re-entry preparations. Their sacrifice reminds us that exploring space has always involved significant risk. Even the question of what to do if someone were to die during a long mission has been considered by scientists. One might assume that releasing the body into space would be an option, but international space law prohibits dumping debris or human remains into orbit. The concern is that such objects could become hazards to spacecraft or potentially contaminate other worlds that scientists hope to study for signs of life. As we continue searching for extraterrestrial life, every discovery, whether it's a resilient bacterium, organic molecules on a comet, or hidden oceans beneath alien ice, reminds us that life may be more adaptable than we once believed. The universe is filled with environments we are only beginning to understand, and somewhere among them may exist another world where life has taken hold. Before we move on, here's a question for you. Which moon in our solar system is considered one of the most promising places to search for alien life beneath its icy surface? Chapter 12. The Future of Space Exploration. As humanity pushes farther into space, scientists are not only solving engineering problems, they are also confronting questions that once seemed purely philosophical. For example, what happens if someone dies during a long-duration space mission? On Earth, funerals and burials follow familiar traditions, but in space, those customs become complicated. Keeping a body inside a spacecraft for months or years could pose health risks for the crew. Some researchers have explored unusual solutions, including a concept developed with a company called Promessa, sometimes referred to as the body-back system. In this idea, a sealed container holding the body would be attached to the exterior of a spacecraft. In the extreme cold of space, the remains would freeze and gradually break into fine particles that could later be returned safely to Earth. It may sound strange, but these kinds of discussions highlight just how seriously scientists are preparing for long missions to places like Mars. Space exploration also leaves behind its own unexpected footprints. In March 2022, astronomers observed a rocket stage crashing into the far side of the moon, creating a crater roughly 27 meters wide. Impacts like this are not entirely new. Several spacecraft components have been intentionally directed toward the moon in the past for scientific experiments. However, this particular crash produced an unusual double crater, something scientists had rarely seen before. The origin of the rocket sparked debate, with early speculation pointing towards space debris from earlier missions. Events like this remind us that even in the emptiness of space, human activity can leave lasting marks. When we imagine traveling to other planets, it's tempting to picture them as new homes for humanity. But many worlds in our solar system are far more hostile than science fiction sometimes suggests. Take Venus, for example. On its surface, temperatures can exceed 460 degrees Celsius, hot enough to melt lead. The atmosphere is incredibly thick and composed mostly of carbon dioxide, creating crushing pressure more than 90 times greater than Earth's. Any unprotected visitor would be destroyed almost instantly. Interestingly, high above the surface, around 60 kilometers up, the atmosphere becomes slightly more temperate. Some scientists have even speculated about the possibility of floating research stations in this region, where conditions are far less extreme. To understand where we might go in the future, it helps to look back at how our cosmic neighborhood began. About 4.6 billion years ago, a vast cloud of gas and dust collapsed to form our solar system. Evidence found in ancient meteorites suggests that this collapse may have been triggered by a nearby supernova, the explosive death of a massive star. The shockwave from that explosion likely compressed the cloud, causing it to spin and flatten into a disk. From this swirling material, the sun formed at the center, while the planets gradually assembled around it. If a supernova helped create our solar system, similar explosions across the universe may still be giving birth to new planetary systems today. But the universe also contains events powerful enough to threaten life itself. Among the most energetic phenomena known are gamma-ray bursts, brief flashes of radiation that release enormous amounts of energy in just seconds. These bursts are thought to occur when massive stars collapse or when neutron stars collide. If one were directed toward Earth from relatively nearby, it could strip away much of our ozone layer and expose the planet to dangerous levels of radiation. Fortunately, most gamma-ray bursts occur in distant galaxies, far beyond any immediate threat to our planet. Meanwhile, modern telescopes are giving us the tools to study distant worlds in unprecedented detail. The James Webb Space Telescope has already begun analyzing the atmospheres of exoplanets, planets orbiting stars beyond our solar system. In one remarkable observation, Webb detected carbon dioxide in the atmosphere of a giant planet located about 700 light-years away. It has also identified molecules such as methane and water vapor on several other exoplanets. These discoveries do not confirm life, but they demonstrate that scientists can now analyze the chemical fingerprints of distant worlds, bringing us closer than ever to identifying potentially habitable planets. Closer to home, our own solar system still holds many surprises. The ice giant Uranus, once thought to be relatively calm, has revealed signs of complex weather patterns near its poles. Observations suggest the presence of a polar vortex, an enormous swirling storm system made not of water vapor like Earth's hurricanes, but of gases such as methane and ammonia. These alien storms remind us that planetary weather can take many strange forms across the cosmos. Exploration continues through missions like NASA's Juno spacecraft, which arrived at Jupiter in 2016 after a 5-year journey. Traveling at incredible speeds during its mission, Juno has provided stunning images and valuable scientific data about the largest planet in our solar system. Its instruments have helped scientists study Jupiter's powerful magnetic field, deep atmospheric storms, and mysterious interior structure. Remarkably, many of the images captured by Juno are processed with help from citizen scientists around the world, allowing the public to participate directly in exploring the giant planet. Even our own star continues to surprise us. NASA's Solar Dynamics Observatory constantly monitors the sun, capturing detailed images of solar activity. In 2023, it recorded a gigantic swirling structure near the sun's north pole, sometimes described as a solar tornado. These massive columns of superheated plasma twist along magnetic field lines, reminding us that the sun is far from a calm, steady ball of light. Instead, it is a dynamic and powerful engine that shapes the entire solar system. As we look toward the future of space exploration, one thing becomes clear. The more we discover, the more questions appear. From distant exoplanets to violent cosmic explosions, the universe is filled with mysteries waiting to be explored. Each new mission brings us closer to understanding not only the cosmos, but also our own place within it. Before we continue, here's a quick question for you. Which planet in our solar system has surface temperatures hot enough to melt lead? Chapter 13: Humanity's Place in the Cosmos. The universe often reveals its wonders in ways that challenge our imagination. Even our own sun, something we see every day, can behave in ways that feel almost alien. In 2023, solar observers recorded an enormous swirling structure near the sun's north pole, sometimes described as a solar tornado. Unlike the storms we experience on Earth, this phenomenon was formed by superheated plasma following the sun's powerful magnetic field lines. For several days, this twisting column of glowing gas stretched more than 100,000 kilometers into space before finally collapsing. It looked remarkably similar to a tornado on Earth, except instead of dust and wind, it was made of intensely hot plasma spiraling through the sun's magnetic atmosphere. While the sun dominates our sky, some discoveries closer to home have been just as surprising. For many years, scientists suspected that water might exist somewhere on the moon, hidden in permanently shadowed regions. In 2009, NASA launched the Lunar Crater Observation and Sensing Satellite, better known as L-CROSS, to investigate this possibility. The mission deliberately crashed a probe into a dark crater near the moon's south pole, sending a plume of debris into space. Instruments analyzing the cloud detected clear signs of water ice mixed within the lunar soil. Later analysis confirmed that frozen water exists in several regions near the poles, offering an exciting possibility for future lunar exploration. If humans return to the moon, that water could one day be used for drinking, oxygen production, or even rocket fuel. The skies above Earth continue to provide reminders that we live in a dynamic cosmic environment. Every year, the Geminid meteor shower lights up the night sky with streaks of bright meteors. Unlike many meteor showers that originate from comets, the Geminids are produced by debris from an unusual asteroid called 3200 Phaethon. As this rocky object travels around the Sun, it sheds small fragments that eventually intersect Earth's orbit. When our planet passes through this stream of debris each December, the particles burn up in our atmosphere, creating one of the most spectacular meteor displays visible from Earth. Despite how vast space feels, the boundary between Earth and the cosmos is surprisingly close. The internationally recognized edge of space, known as the Kármán line, lies roughly 100 kilometers above sea level. If someone could drive straight upward at highway speed, they would reach space in about an hour and a half. This thin boundary reminds us that the transition between our atmosphere and the vacuum of space is far more gradual and far closer than many people realize. One of the most dramatic demonstrations of this boundary occurred in 2012, when Austrian skydiver Felix Baumgartner performed a record-breaking jump from the edge of space. Rising in a high-altitude balloon to nearly 39 kilometers above Earth, he stepped out into the thin atmosphere and began a breathtaking descent. For several minutes, he fell freely through the sky, eventually breaking the sound barrier before deploying his parachute. The event captured the imagination of millions and highlighted just how thin the protective layer of atmosphere around our planet truly is. For astronauts who travel beyond that thin boundary, the experience can be profoundly life-changing. Many describe something known as the overview effect, a powerful psychological shift that occurs when someone sees Earth from space for the first time. From orbit, our planet appears as a fragile blue sphere floating in darkness, with no visible borders separating nations or cultures. Astronauts often return with a deep sense of unity and a renewed appreciation for the planet's delicate ecosystems. The term overview effect, first described by author Frank White, reflects the way this perspective can reshape how people think about humanity and our shared responsibility to protect Earth. Space continues to surprise scientists with unexpected discoveries. In 2014, astronomers found that a relatively small object known as 101999 Chariklo, classified as a centaur orbiting between Saturn and Uranus, actually possesses its own ring system. Until then, rings had only been observed around large planets like Saturn or Jupiter. Chariklo's rings appear to be maintained by small shepherd moons, tiny objects whose gravity helps keep the ring particles organized. The discovery showed that even small bodies in the solar system can host surprisingly complex structures. Beyond our solar system, astronomers are beginning to capture something extraordinary: actual motion of distant planets orbiting their stars. One example is the massive exoplanet Beta Pictoris b, located about 63 light-years away. Over the course of nearly 2 decades, telescopes have collected images showing the planet slowly moving around its star. When those images are combined into a short time-lapse sequence, we can watch a distant world completing part of its orbit. Although the clip lasts only seconds, it represents years of observation and provides a rare glimpse of planetary motion beyond our own solar system. Moments like these remind us how much our understanding of the universe has grown in a relatively short time. From solar tornadoes to distant exoplanets, each discovery reshapes how we see our place in the cosmos. Our planet may feel vast when we stand on its surface, but from the perspective of space, it is a small and fragile world drifting through an immense cosmic ocean. And perhaps that realization is the most important discovery of all. The universe is unimaginably large, yet it has given rise to a tiny world capable of observing and understanding it. Before moving on, here's a quick question for you. What is the name of the boundary about 100 kilometers above Earth that is commonly considered the edge of space? My final opinion. From the violent birth of stars to the quiet drifting of distant exoplanets, our journey through the universe has taken us across some of the most extraordinary discoveries humanity has ever made. We've explored the mysteries of black holes, the strange behavior of distant worlds, the fragile balance that makes life possible on Earth, and the incredible technology that allows us to study places billions of kilometers away. Each chapter reminds us of something remarkable. The universe is vast, complex, and still largely unknown. Yet among all these cosmic wonders, one fact stands out above the rest. Every discovery we've discussed, from the formation of galaxies to the search for alien life, was made by a small species living on a tiny blue planet orbiting an ordinary star. And somehow, against the unimaginable scale of the cosmos, we learned to look up, ask questions, and begin to understand the universe around us. But this story is far from over. New telescopes are being built, new missions are being planned, and somewhere out there, answers to questions we haven't even asked yet are waiting to be discovered. So as we end this journey for now, remember this: the universe isn't just something we observe, it's something we are part of. And the next great discovery might come sooner than we think. If you enjoyed exploring the cosmos with me, make sure to like the video, subscribe to the channel, and share your thoughts in the comments. And before you go, here's one final question to think about. If humanity could visit any world we talked about today, which one would you choose and why? Until next time, keep looking up.